Namaste. So this particular video is going to be about the solution of the question asked in Electronics and Communication GATE paper of 2014 set 3. The subject concerned is mathematics and the question was asked for 1 marks. So let's see what the question was. The question says, which one of the following is a linear non-homogeneous differential equation where x and y are independent and dependent random variables respectively? There are 4 options given and we are told to choose which one of them is a linear and non-homogeneous differential equation. Okay, so let's proceed. The reference for this solution would be any graduate level course on differential calculus, which is particularly taken by BTech students in India, and the other reference can be the differential equation introduction course, lecture 51 of the course by Professor Jitendra Kumar from IIT Kharagpur. It's a lecture course on YouTube through NPTEL. Coming down to the concepts required to solve this particular problem, one would require to know the definition of order and degree of a differential equation, and this is required just to understand what a linear differential equation is. So to know what a linear differential equation is, you should be wary of the definition of order and degree of a differential equation, and then we should be aware about the definition of a homogeneous differential equation, about what is a homogeneous differential equation. If at all we are aware of all these things, this question can be solved straightforward. So let's begin. Okay, so what is an order? See, any differential quotient is written this way, okay, where y is the dependent variable dv and x is the independent variable idv, independent variable. Okay, so if at all you see this thing where the dependent variable is taken as the nth derivative of the independent variable, this particular thing is called the differential quotient. These terms are called differential quotients. Okay, now the maximum value of n, I'll write it clearly, the maximum value of n is called the order of the differential equation. So the highest order of the derivative, that is being taken in a differential equation is called the order, and the exponent or the power, the exponent of order is called a degree. Okay, if these two terms are clear, then we can proceed on with defining the linear differential equation or understanding the definition of the linear differential equation. So what is order? The maximum value of the derivative, highest order derivative, that is order, that is present in any differential equation, and degree is the exponent of the order term. Okay, so for example, we just do an example to understand it better. d2y by dx squared plus dy by dx whole raised to 3 plus something equals to something else, say g of x. This particular differential equation has an order of 2. Order is 2 because the maximum derivative taken is second order, therefore order is 2, but the degree is 1, it's not 3. Don't see the highest exponent, see the highest exponent of the order term, and here the order term is this one, the highest derivative term, and its power is 1 only, therefore the degree is 1. So clear with the understanding of degree and order, let's now proceed on to understand the linear differential equation. So we say that linear differential equation has following properties, or in the other way, any differential equation having the following property will be called a linear differential equation. The first property is all differential quotients, which is all the derivative terms, will have exponent 1. Okay, second would be no cross products of dependent variable terms or differential quotients. I'll make you understand each of these points. Okay, so all differential quotient will have exponent 1, so it is very clear. So what is clear is, at least any differential quotient which is of this particular form will not have any other power but 1. The power will always be 1. Okay, this is the first condition. The second condition says there is no cross product of dependent variable or the differential quotients. That is, you cannot have y dy by dx. That's not allowed. Okay, because you are having product of the differential dependent variable and the differential quotients. Or you cannot have product of two different differential quotients also. This is also not allowed. d2 y by dx square times dy by dx. This is also not allowed. Or in general, any such thing is not allowed. Even y times sin y is not allowed. Okay, you cannot have product of dependent variable with any function of dependent variable, be it the differential quotient. Okay, differential quotient can also be said to be the function of differential variable. Therefore, these things are not allowed. Having followed these conditions, you will come to know, you will come to see that there is only one form of a differential equation which follows these conditions, and that form is what I am writing right now. So it is fn x dny by dx n plus fn minus 1x dn minus 1 by dx n minus 1 plus dot plus f1x times dy by dx plus f naught x y equals to g of x. See, if at all you have this functions here which is only a function of x, if you had the function of y also combined with them, then there would have been cross products. So there would have been a function of y product with the differential quotient, which is not allowed, okay, as per the definition. Therefore, we can only have the functions of x here in multiplication with the differential quotients at all these instants, okay. And similarly, you cannot have anything but the function of x here, otherwise you will have a multiplication of y with some differential quotient or some function of y itself, which is not allowed again, okay. This form of a differential equation is called the linear differential equation. So we are known to the fact of a linear differential equation. Now clearly the degree will always be 1. So degree of a linear differential equation is always 1, okay. See, and the order here is, this is order n, given that fnx is not 0, the degree would be n. Now coming down to what is a homogeneous differential equation. See, if in a linear differential equation, if gx, the term on the right, which is independent of anything related to the dependent variable, be it the differential quotient or the differential dependent variable itself, that term, if it turns out to be 0, this implies the differential equation is homogeneous, okay. So in case you have a linear differential equation, if at all the term independent of the dependent variable is 0, then that particular differential equation altogether is called a homogeneous differential equation, okay. Having known all these definitions, let's go down to the options and see which of the following were linear and non-homogeneous. Clearly the exponent term is 1 here, so differential quotient has power 1, and the function of x is there with y, and another function of x is there. So this is linear because g of x is e raised to minus x, so g of x is not 0 here, but at least on the left hand side you have everything which is linear. You have a function of x, 1 is also a function of x. See, the quotient of dy by dx is 1, which is nothing but 1 x raised to 0, so it is a function of x, right. So some function of x times dy by dx plus some function of x, which is x itself now, times y equals to another function of x. So this is linear, but clearly being linear, it's not homogeneous, non-homogeneous, okay, because you have e raised to minus x here, it should have been 0 for homogeneity, okay, as seen in the definition. Now coming down to this particular differential equation, again there is 1 which is a function of x times the differential quotient plus some another function of x times y equal to 0. So it is linear and homogeneous, okay. Coming down to this particular differential equation, see, you have 1 which is a function of x times dy by dx plus some function of x again times y equals to some function of y, which is not exactly the definition of a linear differential equation. We saw that the definition of linear differential equation requires the term independent of any dependent variable to be a function of x, but this is a function of y, the function of dependent variable. Therefore this entire thing is not even linear. Leave aside homogeneous or non-homogeneous. And then you have dy by dx again multiplied with 1, which is a function of x, plus e raised to minus y, which is again not something which is permitted. You should only have differential quotients or y in a linear differential equation, not some function of y. Okay, therefore this again is non-linear. Hence our answer is pretty clear and straight away visible from here. The only differential equation which is linear and non-homogeneous is not anything but option A. Okay, I hope the solution was clear. Thank you.